Welcome everyone. Today we are going to learn the profile and cross section of map number 6. So we have to draw a profile and geological cross section along line XY, and we have also to interpret the geological history of the area. So this is map number 6. We have already done 5 maps. So let's start doing this map. So very first thing we see in the map are contour lines. What are the values of contour lines and how these contour lines are making shapes, and what are the relationship of these contours with the bedding planes. So as we can see, here is a 400 contour line. This is the lowest value of contour line in this area, and highest value of contour line is 900 in this area and here as well. So we can interpret about the relief variation of the area by the value of lowest contour and highest contour. So the minimum relief of the area is more than 300 feet and maximum relief of the area is more than 900 feet. But minimum relief is more than 300 feet but less than 400 feet, and maximum relief is more than 900 feet but less than 1000 feet, because we are not getting the value of 1000 contours. Now if we see this oval or circular shape and here oval shape, they are representing the hills. So there are two hills which are separated by a valley along this region, and here as well we have a valley, and then we have hills in this region, and in this region height is like this. So hill is increasing in height like this, and here the hill is like this, they are increasing in height like this. So now we have interpreted the topography of the area. The next thing is to see how many beds are present in the area. So in order to interpret the number of beds, we count the number of traces, but we avoid repeating the traces. So here we have 1, 2, 3 and 4 different type of lithology which are being repeated in some manner. So we see this particular axis or this axis or this axis. So along this axis we have a repetition of beds. Along this axis as well we have repetition of the similar beds, and along this axis we have again repetition of the beds. And this type of repetition is cyclic repetition. So let's determine that how the structures and what are the structures which are present over here. So first analyze this axis. Along this axis, across this axis, the two beds are repeating, and then these two beds are again repeating, and then these two are again repeating in cyclic manner. We can take one line over here, so along that we have again repetition. We can take one axis over here, so we have again repetition. So if the cyclic type of repetition is there, this represents the folds in the area. It means the area is folded. Now we have to determine that how many folds are there, that is how many synclines and anticlines are present. So in order to determine the syncline and anticline, we will have to first draw the axes, and we will have to find out the repetition or the direction of bedding planes or direction of limbs across the axes. So in order to do that, we have to draw strike lines on a particular trace. So we choose one trace which is dissected by two same value of contour lines at two places. So here we have one such contour of value 400. So this strike line is of value 400. Now we need successive higher or lower value of a strike line. So we don't have any contour below 400, but we have one contour more than 400 is 500. So the 500 is intersecting same trace over here. So this is our 500. Now we know that the dip direction is from higher value of a strike line to lower value. It means this is the dip direction of the limbs across this axis in this direction. Now we will have to determine the limb dips in this direction as well. For that we can take or we can draw one more strike line. So the value of this strike line is 600. We need another strike line of either value 600 or 500. So we are not getting any other contour on this particular trace, so we will have to go for some other traces, for example this one. So here the 700 is intersecting at two different points. So this is 700. We'll have to draw it with some darker colors. It is suggestible to use pencils, and then we'll have to look for another contour of higher or lower value which is intersecting the same trace. So we have chosen this particular trace. So this is 700, this is 800. 800 is intersecting at this point, so we can draw a parallel line to the earlier strike line. So this is our 800. So dip directions over here are this. Similarly, if this is the axis, the dips, limb dips of this direction will be this, and this direction they are dipping like this. So here the limbs are dipping. If this is the axis, the limbs are dipping in opposite direction, like we have determined over here, and here the limbs are dipping in this direction. So they are dipping in opposite direction. It means this is the axis of anticline, and here the limbs are dipping towards the axis. It means this is the axis of syncline. Similarly here as well the limbs will be dipping in opposite direction. We can see by drawing the strike lines similarly as we have done over here. So as we can see that the difference between the strike lines, that is HE values, are similar. It means the beds are dipping with the same amount but in different direction across the axes. So now we have determined the direction of dip of limbs of the folded beds. So we have one anticline, another syncline, then another anticline. Then if this would have been continued, then we must have got one syncline more. So in this area we have two anticlines and one syncline. Since the core of anticline contains the oldest bed, so this will be bed number 1, and this will be bed number 2, and the pink one over here will be bed number 3. So we will have to represent it with different color so that it is clearly visible. So this will be bed number 3, this will again be bed number 3, and the yellow one will be bed number 4. So this is bed number 3 and this is 4. This is 4 and this is 2. This is again bed number 2. This is 3 and this is bed number 4. So now we have determined the chronology of the beds. So bed number 1 is in the core of anticline and bed number 4 is in the core of syncline. It means this bed must have been deposited unconfirmably over unknown basement, This deposition must be followed by conformable deposition of bed 2, 3 and 4. Then the area must have been put under ductile plastic compression that has produced fold in this particular area. Then the area must have been uplifted and eroded to form the present day landscape. So now let's determine the amount of dip and plot the cross section. So in order to determine the amount of dip, we have this HE. So either we can determine the dip over here, or we can measure this particular amount. This is our HE. We can measure this distance and plot somewhere else. So we are going to plot it here, and we already have CI equals to 0.1 inch because our map scale is 1 equals inches equal to 1000 feet, and of course we have the contour intervals 100 feet. So we can now draw CI. This is length of our HE, and this 0.1 inch is CI. So this is CI, and this value we have already measured is HE. Now if we join these 2 points, we are going to get the dip angle, that is theta. So this is our theta dip angle. Across the axis of anticlines, they are dipping in opposite direction, and across the axis of syncline, they are dipping in same direction. Because the HE in both the cases is similar, so the dip amounts will be similar, the directions will be different. The beds across the anticline, so here the beds which are over here, they will be dipping from X to Y, and these beds will be dipping from Y to X, and similarly these beds will be dipping from X to Y, and these beds will be dipping from Y to X. And here the beds in this direction, they must be dipping from Y to X, and in this direction up to this axis, they must be dipping in this direction from X to Y. So now let's measure this angle. In order to measure it, we will have to increase the length of this line. Now measure the angle. So this is roughly 14 degree. So we are going to take theta as 14 degree for plotting this profile and cross section. So now we will take a blank page over which we have to plot the profile. Now either we are going to use a strip or fold the map along XY direction. So in order to save the time, I am going to fold this map, but it's suggested for new learners to use the strips rather than folding the map. So just orient your XY line and mark the XY points. So these points are XY points. By joining them, we'll get the baseline for the map. Then we have to also draw the positions of bedding planes. So I'm using the red pen for the positions of the limbs of folds. Now, in order to draw the profile, we need the contour values. So we will have to draw the contour values as well. So here with the bedding plane, we have contour as well. So here are bed and contour. Here we have one more contour, and then contour over here, and here we have bed and contour, So this is in fact contour and this is bed. I'm writing B and C for the contours and beds. Then we have one more contour just beside the bed here, and we have one more contour here, 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 here again, one more contour, one more contour. This is the last contour we are getting. Now we will have to mark the values of these contours. So this one is 900, this one is 800, this one we'll have to see. So this is 700, this is 600, this is 500, 500 back, then we have 600, and we have 700, we have 800, we have 900 value, these 2 points, we have again 800, and we have 700, then we have 600, so 700 is over here as well, and this is 600, then we have 500 here and here, 600 back again, then we are getting no other contour in this direction. So here we have got one more, have to mark it as well. Now we can draw the baseline by joining points X and Y. So this is our baseline. Now in order to draw the profile, we will have to draw the contour values. By projecting the contour values, we will get the profile. So since the values are varying between 400 to 900, we need only up to 1000 value of contour. So we can mark now 0.1 inch is equal to 1000 feet. This point is Y, this is 0, this is 100, so I'm writing 100, then this is 200, this is 300, 400, 500, 600, 700, 800, 900 and 1000. Similarly, in this direction, we'll mark the values. This is baseline, so 0 feet. This will be 100 feet. This will be 200 feet. This will be 300 and this will be 400 feet, 500, 600 feet, 700, 800 feet, 900 and 1000 feet. Now we'll have to project the height of contours. This is 900, projected height 900. This is 800, projected 800. This is 700. So now we will project it at 700. This one to 600 because the value is 600. These two at 500. This is 500, and this is again 500, then we have 600, then we have 700, then again we have 800, then we have 900, we have 900 over here as well, 900 in repetition, then we have 700, then we have 600, 500, and then 500 back again, we have 600. If next one will occur, it would be 700. So by joining these points between 700 and 600, we can draw a profile. We will join these points with a smooth hand and we will get the variation of relief or the shape of profile in the region. So this is the increasing trend. The next one must be this is 900. The next value will be obviously 1000. So this will go in between 900 to 1000. So this is the shape of profile this we get by joining the contour heights with a smooth hand. So it means if you start from walking from x to y rather than a plane, you are going to get the variation in the altitudes. The first altitude drops from 600 to 500 and that increases up to 900, and then again it decreases up to 500 and then again increases 900. So this is the way you are going to get the relief variation from line x to y. Now let's see, if we slice this area along this line vertically, what will be the nature of beds and how the beds will look like within the subsurface. So that is actually our cross section. For that we need to plot the beds with the determined dip amount and dip direction. So we have already determined the dip amounts are 14 degree and they are varying across the axis in direction. So here is one axis and here is another axis. So in between these axes the beds will be dipping in this direction, and between these the beds will be dipping in this direction. Similarly in this direction up to this axis, and then we will be dipping in this direction because this is the axis of anticline. So along the axis of anticline the beds dip opposite to the axis, and in the axis of syncline the bed dips towards the axis. So now let's plot the position of beds onto the profile. So here is one bed, another bed is over here, one is here, another is here again. We have one bed over here. So in order to draw it accurately, we can also use some scale or protectors as guidelines. So these are the points. Now we will plot the axes at approximate distances. So along this line there is a repetition. The axis must be somewhere in between. Another axis must be somewhere here. Another axis must be somewhere here. By joining the limbs, we will get the exact position as well. So this is the axis of anticline, means the beds in this direction will be dipping in this direction, and across the axis they will be dipping in this direction. And this is axis of syncline, so the beds will be dipping like this, and again this is axis of anticline, beds will be dipping like this. So now let's plot that angle at the base and draw the limbs. So just put an arbitrary point onto the baseline. So once you have put that point, draw the angles. So this is the amount for which it is roughly in between 14 to 15 degree the limbs of the folds are dipping. This is our theta. So the beds which are in this direction, they are going to be parallel to this angle. So in order to draw it parallel, we will have to use some protectors. So above they are eroded, we can extrapolate it to see that how originally they must have been. This is not necessary to extrapolate it, and we can at the same time draw these beds as well parallel to this line. But before that, let's complete 1/4. Be careful while orienting the protectors. So here is one bed. This is going like this, the subsurface, and above this is going like this. This is another bed. So in subsurface they must be going like this, and above they are going like this. We'll find out and how they are joining. In subsurface this is going like this, and above they must have been going like this. So here the beds are going like this, so they are folded rather asymmetrically like this. So here is somewhere axis. Now we'll have to plot these beds. So they are again dipping in this direction. Because the beds are folded, so So they must not be extending. Here they must be going like this before erosion. Now, across this axis, the beds are dipping in this direction. So here is one bed. This is situation before erosion. Here is another bed, and here we have one more bed which must be going somewhere like this, and this bed must be present above the profile before the erosion and after erosion. Now it is present below the profile, but above it has been eroded. Now we smoothen these positions, we will get the real shape of the beds in the subsurface, because most of the faults except accordion and Severan faults, they join smoothly or they bend smoothly rather than by sharp hinges. So we will use so this is our axis frantic line. Similarly here we'll join it with smooth hands. So beds are dipping in subsurface like this. This is axis of syncline. Here they must have been like this before erosion. Now we can fill the symbol. Now let's smoothen these profile lines so that we can see. This is our profile line above which the things have been eroded. So they are not present now. We have drawn it with dissected lines, the features which are not present now, and we will use solid lines for the features which are still present. So these are the beds which are still present. After drawing this, we will fill the symbols. So this is how the beds are present in the subsurface. Now we will use the same symbols which has been used in the map. So here the bed number 4 has been drawn by yellow color, 3 by pink one, and the 2 has been given a 3 dot symbol with a red pen, and bed number 1 is in fact represented by coarse black dots. So bed number 4 is this one. So this is represented by black coarse dots. We fill this type of symbol for bed number 1. Now even we can remove this baseline if we want. Otherwise, you can leave it such as. Let's mark axis clearly. So this is axis of anticline, this is axis of syncline, this is another anticline. And fill the symbol. So bed number 2 is represented by red triangular dots. And bed number 3 is represented by pink color. This is bed number 3. Above the profile, these beds have been eroded, but they must have been present before erosion. And the bed number 4 is represented by yellow color. So these are the bed number 4. This is present over here, then here, back again we have here as well. So now we can compare our cross section with the map. So we start walking from X, we get for a certain distance bed number 4, and then we get bed number 3 for this distance here, and we get the bed number 2, we are getting the bed number 2 up to this distance. The bed number 1 from this distance to distance, this is bed number 1 which is exposed from this distance to this distance. Then we again give bed number 2, we are getting bed number 2, then bed number 3 and bed number 4 from here to here. Then we again get bed number 3, so we are getting the bed number 3 from this position to this, then bed number 2, then again bed number 1, then bed number 2, then 3, then 4. So our this cross section is perfectly drawn. So this is geological cross section along XY line. So this is actually XY line, and the real X point is over here and Y is over here, and this is how the shape of profile is varying. So we are done with the cross section. Now we will have to interpret the geological history of this particular map. So we discuss these things within 4 points. So what are those 4 points? Those are in fact, the first point we discuss is topography. Second point we are going to discuss is structures present. Structures. Third is order of superposition. And fourth point, geological history. So let's keep the map above and discuss these things. So topography of the map, the minimum relief of the area is more than 300 feet and less than 400 feet, and maximum relief of the area is more than 900 feet but less than 1000 feet. Second point is structure. So we have already determined that there are folds present in the area. There are 2 anticlines and 1 syncline. So a structure is four folded beds consist of 2 anticline and 1 syncline in manner anticline, syncline, anticline. Then order of superposition. So for that we will have to draw the sequence before deformation. So initially the beds deposits in horizontal manner, and because of deformation the horizontal beds have been folded. So there are 4 beds, 1, 2, 3 and 4. The first bed is represented by ghost dots, and this bed must have been deposited over unknown unconformable basement. Then we have bed number 2 that is represented by rectangular dots. Then we have bed number 3 which is represented by scalar, and bed number 4 which is represented by yellow color. So now we can interpret the geological history that bed number 1 must have been deposited over unconformable basement unconformably. Then the bed number 2, 3 and 4 must have been deposited conformably. Then the area must have been put under ductile compression that produced the folds in the area. Then the area was uplifted, tilted and eroded to form present day landscape which looks like this. And if we draw the cross section along this line XY, the cross section looks like this. Thank you everyone. In the next class we will be learning the map of faults and some other geological features. So once again, this is the map and this is the cross section of the map. Thank you.